Welcome back, Bulldogs. It's Miss Adams again. So let's continue lesson 9.1. Remember, lesson 9.1, we're going over average rate of change. Our last video, we were looking at graphs. So this video, we're going to look at tables. So for our tables, we're going to state what type of function each table is, and then determine the average rate of change for the given intervals. Then circle if the AROC is constant, so it stays the same, or varying, so it's changing. Let's look at our guide notes, question 7. So I've got x values that are increasing by 1 because we're going -2, -1, 0, 1, 2. So each of those are increasing by 1, by increments of 1. And then let's look at our y values. So 7 to 10, that's an increase of 3. 10 to 13 is also an increase of 3. 13 to 16 is an increase of 3, and 16 to 19 is an increase of 3. So every time our x value increases by 1, our y value increases by 3, making that a linear function. Another way you could look at it, if you weren't just identifying the table, you could graph it, but we're looking at tables, so let's keep it that way. Now we're going to look at the interval from where x equals -2 up to 0. So at -2, y equals 7. So we've got -2, 7, and 0, 13. So now we're going to do our differences here. Your difference of your y is going to slide down to the top. So I've got 7 minus 13 in my numerator, and -2 minus 0 in my denominator. 7 minus 13, that's going to give us -6, divided by -2 minus 0, which is -2. So that's going to reduce to an average rate of change of 3 for our first interval. Second interval, when x equals -1, y equals 10. And when x equals 2, y equals 19. And we're finding the differences here again. So let's slide that down. So we're going to have 10 minus 19 divided by the difference in our x values, which is -1 minus 2. And let's simplify. 10 minus 19 is -9. Divided by -1 minus 2, which is -3. And that reduces to 3. Negative divided by negative is a positive. And 9 divided by 3 is 3. Noticing that the average rate of change for our intervals are the same because 3 equals 3. That makes this function have a constant average rate of change. All right, let's go over to problem 8. So this is our second table. Let's see if we can see a pattern here. So when I'm increasing by 1 in my x's, so -2, -1 is 1, -1 to 0 is 1, 0 to 1 is 1, 1 to 2 is 1. Let's see if we've got a pattern on our y's. So 5 to 2, that's a difference of 3. 2 to 1, that's a difference of 1. 1 to 2 is also a difference of 1. And 2 to 5 is a difference of 3. So that's a symmetric pattern. If we think back to our functions, a function that is symmetric would be a quadratic function. So we have identified our function type. Now let's look at our average rate of changes. So our first interval is going to be from where x equals -1 to where x equals 0. So our first values there, we've got -1 for our x, 2 for the y. And looking at the table where x equals 0, y equals 1. So let's find our differences here. The differences in y's is going to be 2 minus 1. And we're going to divide that by our differences in x's. So that's -1 minus 0. 2 minus 1 is 1. Negative 1 minus 0 is negative 1. So that gives us an average rate of change for this interval of negative 1. Now let's look at the interval from 1 to 2. When x equals 1, y equals 2. And when x equals 2, y equals 5. So I'm going to find my differences in x and my difference in y. So in my numerator, I'm going to have 2 minus 5. And in my denominator, I'm going to have 1 minus 2. 2 minus 5, that's going to reduce to negative 3. 1 minus 2 reduces to negative 1. And negative 3 divided by negative 1 simplifies to 3. All right, let's look at the average rate of change for those intervals. Negative 1 does not equal negative 3, so therefore the average rate of change for this function is varying. Let's go to our last function. So problem 9. Let's look and see if we see a pattern here. So once again, we're increasing by 1s in our x's. But now, instead of adding, we're going to be multiplying on the right-hand side. So 0.25 times 4, or if I say 1 divided by 0.25, that's going to be 4. So that's a multiple of 4. 4 divided by 1 is also 4, or 1 times 4 is 4. 4 times 4 is 16, and 16 times 4 is 64. So because we are multiplying instead of adding, this is going to be an exponential function. All right, so let's look at these average rates of change for the different intervals here, just to see how they compare. If my x value is negative 2, my y value for this function is 0.25. I'm going to write that down in my t-chart. And then if I'm looking at where x equals negative 1, y equals positive 1. We've got negative 1 and positive 1. Let's find my differences. So we're going to have our change in y on top. So it's 0.25 minus 1. And then on the bottom, I've got negative 2 minus a negative 1. Remember, minus and negative is adding a positive. So I've got on top, I'm going to have negative 0.75 divided by, well, that's negative 2 plus positive 1. That's going to be negative 1. So that gives us an average rate of change for this interval of 0.75, or 3/4. All right, let's look at the next interval. I'm going to go from where x equals 1 to where x equals 2. When x equals 1, y equals 16. When x equals 2, y equals 64. So let's find the differences in our x and y's here. Using our slide, we're going to slide over and see that 16 minus 64 is divided by 1 minus 2. This is going to simplify to negative 48 divided by negative 1, which is going to give us an average rate of change of 48. Whew, that's a big average rate of change. Notice, though, comparing them, 0.75 definitely does not equal 48. So our average rate of change for the function is varying. All right, guys, you try the last 3. Have a great day.